The topic today is AI and Wi-Fi with Mist Systems. And I have Bob Friday, who is the CTO of Mist, as well as Jeff Aaron, who is the VP of Marketing. Hello.
Good afternoon, Michelle.
Hey, Michelle. Thanks for having us.
Yeah, my pleasure. So the topic is AI and Wi-Fi. First, I would like to really hear about what your stories are.
Yeah, hey, Michelle. Yeah, this is Bob here. So, just maybe give you a little bit of background. My experience with AI started back in my early days in Metricom Wireless. And I think, one of my stories is when I started the Metricom adventure, I was really a software engineer, and I was too young to know it, but I ended up becoming the guy that built all the radios there. And that was kind of one of my life experiences. Hey, sometimes it's better to know less than anything else. That's how I kind of got into the wireless space. And then when I started this Mist adventure, it's basically another transformation, right? Now I'm all about AI. We're really on the adventure of really building a virtual assistant here. So that's kind of my background story of how I kind of migrated from software to wireless to AI.
That's awesome. How about Jeff? How about you?
Yeah, well, I've been in the networking space for a while, like Bob, and what interested me is about a year and a half ago, I had heard some of the things that Bob and company were doing over at Mist, particularly around bringing AI to the networking space. And I had known Bob. We worked together about 15 years ago, and so when I saw some of the folks at the Mist team, it just seemed like a great opportunity to get on board and get the start of this just new technology and new foundation with AI-driven wireless, and it was really exciting. So I jumped on the opportunity.
That's awesome. So I met Jeff at a Star Wars show, and we invited a bunch of my friends, and we were really interested in learning a lot about AI. I also run a community called Robotics for Good, so I am pretty familiar with the topic. So tell us about Mist Systems.
Yeah, so if you look at Mist, I think we're focused on two things here. One is just really building this virtual AI assistant to really answer questions on par with a domain expert. The other thing we've become focused on is really around bringing the indoor location experience on par with the outdoor GPS experience, leveraging BLE.
Bluetooth Low Energy.
Bluetooth Low Energy. And that also has kind of a interesting machine learning aspect to it around how we leverage machine learning to do unsupervised machine learning to eliminate the need for site survey. So that's a little bit about Mist. When you think about Mist, think about virtual AI assistance for IT, and think about bringing indoor location on par with GPS.
So before we get into the AI and a deep dive into that of AI and Wi-Fi, I wanted to just really understand more on the macro level of Mist Systems. Tell us about your customers.
Yeah, I think Jeff and I both have good customer stories. I think, for me, the Veterans Administration is probably a good example of a customer we're working with around on AI right now. And it's really around two aspects where they're trying to bring, to the veterans, they're trying to bring this guest Wi-Fi experience. And that's really around leveraging AI to provide better visibility all the way down to the end user experience. So when the veteran walks into the VA hospital, they actually know what type of connectivity experience that user is having. And the other aspect we're working with, the Veteran Administration on is really providing a better wayfinding experience, right? So when you walk into a big venue, yes, I need to know you have good connectivity, but I also want to start bringing this location experience to where we can help the veterans get from point A to point B. And then there's even a third aspect where, we're working with them on bringing better asset tracking visibility to the market, right? Trying to help them do a better job providing services to the veterans while they're there.
Yeah, and I think internet and Wi-Fi is super important, because I've been to conferences where there's no Wi-Fi at all, and it was very frustrating. So who are some of your competitors in this space?
Yeah, I can maybe answer that. So it is interesting that at the most rudimentary level, we are a wireless company, And so we are competing with a variety of the traditional Wi-Fi vendors that are out there, the likes of, the Aruba HPs of the world that have been selling Wi-Fi for over a decade. And that's what's interesting about it is if you look at most of the Wi-Fi that you're using, when you walk into a Starbucks or when you walk into a McDonald's or even on Stanford's campus, most of those technologies were built prior to 2007. Mm-hmm. So they actually were built, and Bob and I were involved with them. We helped build them. But they were built prior to the modern cloud, they were built prior to the modern smartphone, and they were built prior to AI really existing in its current form. And so that's where Bob and team kind of took a step back and said there just hasn't been a lot of innovation in the last 10 years. So how do we redo Wi-Fi so you get better visibility into the user experience and automate it using AI so it's just easier to operate and lower cost? And then how do you bring on these new location services on it like directions and push-based notifications, which you just couldn't do 10 years ago, and that's where we came about with Mist.
Yeah, because it's kind of an interesting question, right? Because if you look on the location aspect, partners like Cisco actually ODM are some of our technology on the location side. On the wireless side, we compete with all kind of the standard wireless, Aruba, Ruckus type of competitors out there. But when you look on the AI side, there's really, I would say, not much competition because the legacy wireless players really don't have the architecture they need to deliver kind of these real-time AI services. So it's kind of an interesting space where we both compete and cooperate with our partners out there, depending on what we're working on.
Yeah. So Bob, I've spoken with a few of my friends, and I told them that I'm going to be speaking with you both today, and they told me that Bob Friday is an OG of Wi-Fi. So how does the idea come about?
Yeah, so this one came back, for people who know my background, I was the co-founder of Aerospace, which was really around helping enterprises deal with all these employees bringing laptops into the enterprise space and everything. Mist really came about from two things that really influenced me. One was talking to customers, a lot of the wireless customers, and I can specifically remember talking to one where he was like, hey, Bob, for you to do all this fancy stuff, I need you to kind of make sure that all your controllers don't crash. He also made a point that I really need visibility down to the end user, right? Because if I'm going to put something on my network, right, because it was all about mobile engagement and actually helping actual end consumers, right? It really wasn't about employees this time around. Mm-hmm. It's really about enterprise. It's really about helping enterprise businesses put services onto these wireless networks. And so that was kind of the beginnings of, Aerospace was all about helping enterprises helping IT put employees on their networks. This time around, it's more about helping businesses put critical services on the wireless networks. Mm-hmm. So that was kind of one data point that got the Mist, the beginnings of a twinkle of mist in my eye. The other thing is, Sujay, who's my co-founder with me, the other thing is, I don't know if you remember Watson, when Watson played Jeopardy in 2011?
IBM.
That was another critical thing where it's like, hey, guys, if we can build a piece of software that can play Jeopardy on par with a world champion domain expert, we should be able to build a piece of software that can answer wireless questions on par with a wireless IT person. And so those were kind of the two driving factors behind Mist that said, the technology's here, it is possible, and there's a need, right? There's actual mm-hmm. customers now. There's a transition in the marketplace going from helping employees to helping actual end users and putting more services on these networks. And then really the technology is available. This AI technology is actually becoming real.
So, I just wanted to transition that, from the reality of AI. So I do work in different nonprofit humanity projects, as well as the community. And so my question to you is, so we have Wi-Fi now, right? And of course, we also have AI. But why do we need AI for Wi-Fi? I mean, why do we need AI for the air? And why does it need to be misty? I'm just playing with that metaphor.
Brings a tear to your eye, doesn't it?
If you step back, I think there's a couple, if you look at a very high level kind of macro trend, right,
Mm-hmm.
I think we can all agree our society has gone mobile, right?
Mm-hmm.
I think we are all starting to live in a very mobile world. An interesting data point, if you look at kind of the Cisco VNI data, you'll find that 60% of all internet traffic is basically being carried on a Wi-Fi network somewhere. So Wi-Fi, where cellular has become kind of the de facto outdoor access network,
Mm-hmm.
Wi-Fi is becoming your de facto indoor wireless network. And when you look at wireless, what it takes to get a packet from that web server down to your mobile phone,
Mm-hmm.
There's about 10 different things that can go wrong. And that is really where, when you talk to a real IT network person who's trying to make sure you have a good experience at the end of that, from that internet server down to your phone, there's really a ton of data that goes behind it. When that packet doesn't show up, it's almost like a detective story, right?
Yeah.
It could take an IT person days to kind of figure out why you, Michelle, are calling him up, right? You're basically telling him that your wires, something happened, I can't get to the internet, and it becomes a very much like a detective.
Yeah, and I may elaborate on that. So, Michelle, let's say you're an IT person, and someone showed up on Stanford's campus and you couldn't connect, and you call the IT help desk, right?
Yeah.
They would have to send someone to your location. They would have to take a sniffer. They would have to try to figure out what channel to sniff on. They'd try to recreate the problem. The problem could have been due to the fact that you had 50 students in a classroom and now there's only one.
Mm-hmm.
It could be the fact that someone moved a filing cabinet, someone opened a door. So to recreate that problem, as Bob pointed out, is very time-consuming, very costly, and it just leads to a crappy service for the people in the Wi-Fi. And AI can help, right? So if you're collecting an enormous amount of data in real time, you have all that information right at your fingertips to troubleshoot it or to prevent it entirely.
And I try to explain to people, IT. People working in networking IT are very similar to doctors trying to diagnose cancer, right?
Yeah. So I can tell you guys a real-time story at the Stanford campus. So I was at the Stanford Bitcoin Club on Sunday, from 5:30 to like about 8:30, to hear Charlie Lee speak about Litecoin. And there were about 700 people who were interested in the event, and the location building 200 seats, around probably about 100 people, and the room was really packed. And we were using the Stanford Wi-Fi, and all of a sudden it just didn't work. So I used to work at Cisco, and my friend actually is a professional person at Cisco. And so, we noticed, that because there's probably a lot of people there, it just slowed down the Wi-Fi to a point where the network did not work at all. So basically, you're saying that with your system and with your technology and AI, you could basically find out what causes that and then fix it in real time. Is that correct?
Yeah, so that's correct. Or another interesting example that we're seeing in educational environments like yours is you can say that I want everyone in a conference hall or a room to get at least 10 megabits per second throughput when they connect.
Mm-hmm.
What's cool about something with AI and the Mist solution is you can actually predict. So you can say not just who's getting it right now, but at 10 a.m. tomorrow, if there's 400 people in the room and they're all connecting, is this a service level I can meet? And so there's an example. We could say, all right, if there's 400 people in that room, what kind of service are they going to get, and do we have an issue or do we need to do something to fix it? So that's an example where predictive recommendations in AI could have helped solve that problem.
And I think you're right. I mean, I think the vision as we start going forward is we're going to see networking infrastructure becoming much more intelligent with AI assistance,
Mm-hmm.
which will definitely help both the IT departments resolve things faster and eventually get to the point where you as a user can actually get into self-serve mode, so you actually can figure out what's going on with your device without the help of IT. With the ultimate goal of, I think we're also going to see network infrastructure become much more self-healing, right? As the networks become much more AI aware, they will also become more self-healing. Because up to now, networks really didn't need to be self-healing, right? Because we basically had people running around manually configuring things. So I think that's the trend we'll start seeing networking head into, as well as other industries, right, as AI becomes more relevant to it.
Yeah. And it's also worthwhile to point out, we're talking primarily about, the Wi-Fi experience and the Wi-Fi operational, but the other key aspect is adding personalized location services on top of that. So if you did show up in that room, for example, Stanford Law is actually a customer of ours. So if you show up on campus, it does have the ability to wake up your application, give you directions on where you're going, help you find an open conference room or study room, push notifications like get free flu shots if you're near the nurse's office. So that's kind of the other next generation of wireless. It's all about personalizing the location experiences on your wireless network, which AI enables as well with the machine learning.
Can I ask you?
So Stanford is the leading front.
Can I ask you if that's related to the blue dot?
Yes, I mean, so I would say, when we look forward to more intelligent infrastructure around helping virtual assistants, the other big trend that's happening in the industry right now, and that, I've been working on indoor location for a while, is really around, are we going to see BLE go from a nice to have to a must have, similar to what we saw with Wi-Fi, And I think there's a good chance that may happen because, what happened with Wi-Fi is when Intel put Wi-Fi into our laptops, that was kind of one of the catalysts that really made Wi-Fi go from a nice to have to a must have everywhere. We're seeing something similar with BLE. Apple and Google basically have put BLE into all our devices. And the other big thing is really converging BLE and Wi-Fi.
Mm-hmm.
One of the big problems with indoor location is always required an overlay network. So by converging BLE and Wi-Fi, we've kind of eliminated two of the biggest impediments to bringing indoor location to a must-have status.
Awesome. And please feel free to be as technical as you want. So I do understand the technology, both in the networking space and the AI space, because I used to write a lot of the technical documents for Cisco. Because, VPNs and voice over IP and iOS, so I'm familiar with that. And I'm also also in the telecom space as well. So, and also AI. So, I think it's just a big convergence of all those, spaces, which is really exciting and awesome. So we are going to deep dive into AI. So it's going to be pretty interesting and awesome and hopefully informative to the community. So why is there so much interest in AI machine learning as of late? Is it a fad or a truly transformational technology?
Yeah, I think that is a good question because most of these concepts, and a good point in mind, a good example is, back when I founded Airspace, we did a bunch of location stuff around Wi-Fi back then, but there was a bunch of things I couldn't do, like unsupervised machine learning, right?
Mm-hmm.
Back then we still had these site surveys to learn these path loss models. You basically had to walk around, collect a bunch of data, and figure out what the path loss model was for a given device and location. That problem today here at NIST, I was able to basically do it, and it was for a couple of reasons. One is the open source trend. There's basically a bunch of open source code that is around now that wasn't around before. And if you look at NIST, we probably have 20 or more open source packages we use to deliver our functionality right now. The other thing is the compute thing, right? 15 years ago when I did Airspace, I was trying to do all this stuff on a 1U Linux box. Now I don't have any limitation, right? My only limitation is my Amazon bill. I mean, I can spin up as many servers and use as much memory as I can to solve a problem. And unsupervised machine learning is an example of, that's very matrix intensive math to basically take all this RSSI information and try to figure out the path loss model for every device and every AP. But now I can do it. So, to your question, I think that is why AI is starting to move from a, kind of a concept to reality. And when you look, I think another interesting data point is actually I don't know if you've been tracking all the quantum computing stuff.
I am. I
But
met IBM at CES just I think a
yeah,
week or two ago. Yeah, they had their display of the quantum computer, which is really awesome, by the
yeah,
way.
yeah. No, but you look at that and you think about it. It's like, if you go to the Gartner, if you go to Gartner now, quantum computing actually shows up on their hype cycle as a real technology.
Hmm.
There's real startups like Rigetti and Quantum Clicks, I think, out there that are actually building quantum computers, for commercial, right? For commercial use.
Hmm.
Um, so it's just kind of amazing. There's a confluent of three things: open source code, cloud computing with enough resources to actually do it. And so now all the data scientists that have been around for hundreds of years actually have all the tools they need to make this AI stuff really work. So I think we're I think it is going to be transformational. I think it's going to be up there with the internet in terms of our society.
Hmm.
I saw something in the Gartner thing that AI will it'll eliminate maybe 1.8 million jobs, but basically on net, there'll be 2.3 million new jobs created by AI.
Yeah, yeah,
Um,
and I would like to add the conversions of computation and distributed computation, as well as networking, which is really what you guys are doing.
yeah, so it's going to be a fun decade. It's going to be I think this is going to be the decade of AI in front of us.
So, what's the difference between AI and machine learning for the community?
It's a great question.
Yeah, that's a tough question. I try to explain to people that to me AI stands for kind of the interface. AI to me is basically the face on top of all the machine learning algorithms.
Hmm.
Usually when I think of AI, I think of Alexa or something I interact with, a virtual assistant or a chatbot. So I think of AI being this overall encompassing concept with kind of natural language processing on the surface.
Hmm.
And when you look underneath it, you find all the machine learning algorithms, whether they be neural networks or regression models or statistical data mining models.
Hmm.
That's kind of my definition of AI versus machine learning.
Yeah. So I like for me, AI, it's encompasses linguistic language programming, machine learning, and digital assistant. I'm working on a project called Loving AI Project, which is part of the Watson AI X Prize.
Yep.
And then I also work on another nonprofit that does a Luna chatbot that helps with education, humanitarian aid, as well as medical assistance. And, but I think there's a number of machine learning in there too because of recognition, as well as NLP because of the voice. And then digital assistant, of course, because, a lot of them, Sophia the robot, has or helping people, right? They're essentially chatbots as well. So I think it's interesting. I think machine learning, with like RNNG and and then concurrent neural networks as well, are more deeper because then they translate and match and discriminate, right? So I think when we dive deeper, I think there are differences, and each machine learning differences has different uses as well. So I think that's my experience with, or that's how I define the difference between AI and machine learning. I feel like machine learning, it's part of AI and they overlap.
Yeah, I mean, I think if you look at when we're building our what we call Marvis or virtual AI platform
Mm-hmm.
here, it has what I call different components, right? We have kind of the data, the raw data that we get from the edge of the access point, and the edge of the network. We have domain expertise where we provide structured metadata, right? We take that raw data and put it into some metadata that a domain expert would understand. And then we have a data science toolbox, right? And that's
Mm-hmm.
kind of where all the machine learning stuff lives. And that toolbox has, a variety of different interesting tools on it. And then on top of that is where kind of the natural language processing, right? You got to put some way to get the data out of it, right? You got to make it easy for the users to actually interact with all these machine learning algorithms that you have running in the background.
Yeah, so you're talking a little bit about how the machine learning is utilized. Do you, and of course, data seems like it's king right now in the context of the world around us and the technology. So do you train, your machine learning with data that you get from customers? Yeah.
Yeah, I mean, I think this is what I'm saying. In that data science toolbox, there's kind of the classical supervised concurrent, your neural networks, right, where you have labeled data. Like if I want to basically predict your internet speed, right, I will have labeled data from which I can basically train a neural network to answer that question. There's other things like when we work on location problems, that's more of an unsupervised training model where it's like we don't have labeled data to work with. What we have is a bunch of data coming at us, and we basically have to develop algorithms that learn the model without any labeled data, which is a little bit trickier to actually get that to work.
Yeah, but I think that's the IP. I mean, if you get to work, if you get that to work, that's basically the value, right, of the company.
Yeah, that turns out to be, everybody asks me, how did you do that? And it's like, well, it gets down to, yes, you have to have a proxy for the labeled data.
Yeah. The other thing that is interesting is, with the cloud architecture we use, you can actually look at, metadata sets across, different customers, so you can actually see trends and use AI to detect that. So are iPhones having an issue, or are all iOS devices having an issue, or, is the latest version of Android, did the BLE signal strength go down? So there's some pretty cool things you can do with that data set in terms of trending analysis and anomaly detection, which is pretty cool and just couldn't be done, again, 10 years ago.
Like when we do our location stuff now, I can tell you now from looking at all the data, who hears BLE better, Android or Apple, right? Because we're basically constantly learning and training on how well, on that path loss model, I know which ones actually hear BLE better than the other ones. So at a global level, you start having visibility across all these different type of devices out there.
Do you also get, from a telecom perspective, do you also get data about which network's better? Because I have AT&T, right? Is that better than the other, T-Mobile and the other telecom companies? You get that data as well, right?
We don't get on cellular. Right now, we're focused on Wi-Fi.
Oh, okay. Got it.
So we have that same visibility across Wi-Fi networks. We know what the difference is between all the various Wi-Fi networks out there.
Okay, and what are some of the other AI success stories besides all the data that you guys get?
Yeah, I think, from my perspective, there's some, there's kind of the classical ones of Facebook, face recognition and Alexa that are going out there. But I think, from an impactful point of view, I think what we're seeing in healthcare is probably the most, from a societal point of view, right? We're starting to see AI really make a difference in cancer diagnosis, right?
Yeah.
And that's really tied to, and I think, Google and TensorFlow, they've really shown that these neural networks have reached a size now that they can really solve image recognition problems, right? We've got enough compute power. I remember back during my master's, I did a neural network thing, and we really just didn't have the compute power to solve interesting problems. Now, healthcare guys can really diagnose cancer, right? They can basically take a picture of a tumor and compare it and basically give you a pretty good diagnosis of whether or not that's going to be a cancerous tumor or not. So that example is where AI is going to, is making a really difference in healthcare diagnosis.
Yeah, Bob's other favorite example is using AI to grow better grapes for wine.
Yeah,
some good stuff there too.
If you look across any industry right now, AI is having an impact, whether it's in the wine industry or in our wireless space. AI is being applied to almost, I'm not for sure there isn't an industry that's not going to be impacted by AI in some form or fashion.
No, I personally used AI in education. So I was helping certain students with a certain subject, and I created AI. It's a little bit over the top. I created AI bots to help them study, and I don't think they even know that that they're using that some of their study materials are contained digital assistants. Yeah, to help them pass the test.
What grade was this?
High school, AP tests.
Okay.
Yeah, I just make them personally, and it was fun for me, but it's I can see AI big in education, and I did volunteer at a distributed computation for cancer project last year. So I think average cancer project was about, just computation was about 40, I think it was 20 to 40 million or so. But with distributed computation, it reduces the cost to about 100,000 per project. So and that is with, I think, 1 million devices plug in. So I think it's just really the trend toward decentralization. So the distributed computation, we have self-diagnosis with, using your cell phone to take a picture of a symptom, and checking the databases to see what it is before you go to the doctor, and also what you guys are doing with the Wi-Fi and AI. It's super super awesome.
Yeah, I mean, like in your case, so you use distributed computing along with a kind of a neural network model or kind of a regression model to solve a problem. You were using distributed computing across a bunch of small computers.
Yeah. So the distributed computation, it just the power behind different devices, solve cancer problems for the world community grid.
Yeah.
And then then outside of that, there are I also run a cancer moonshot community, I guess. And so, we share about different AI news all the time related to cancer. And so there are companies that are using AI to detect cancer, or even, before it forms. It's just super, super awesome. I mean, and besides changing cell signaling and other stuff to treat cancer, I think it's just different angles of solving a problem, and then I think it just converges, right, at some point.
Yeah, I mean, I think the more interesting, I don't know if you follow the Qualcomm guys, right? I mean, the Qualcomm guys are starting to build silicon that's really optimized for all the matrix multiplies and doing the neural network on your phone, right?
Mm-hmm.
So they're starting to push that processing all the way down into your phone, so you basically do this image classification on the phone itself, right? So you don't have to bring all the video back, and basically start doing it right at the edge.
Yeah.
So
I think there is a lot of companies using AI in video as well, and with the amount of computation that we use, we need to have awesome Wi-Fi, right? I mean, I can't stream something when I'm in a room, like CS with a lot of people, because we don't have sufficient coverage. So I think as society and technology has a high demand, we need, our Wi-Fi. It's like, people say Wi-Fi is life, right? And I think it is true as a user, as an end user, by the way.
I've been in wireless for a while, and it seems like there's got to be an easier way to make a living, but I think that's what I always tell people, right? Wireless is much more like statistics. If you have to ever take statistics and random variables in college, it's really tough. Wired network is much more like algebra. It's very deterministic. And I think that is why it is kind of a dynamic living thing, right? It's never consistent. It always changes.
Mm-hmm.
If it's not working, wait a minute. But I think that is the, why, back to your question, yes, and we'll see our Wi-Fi networks and networks in general become more AI aware. They'll become much more intelligent. And then I think you'll see them become much more self-healing, right? As we add more intelligence into the network to make it more aware of itself, it will actually, we will also start building more self-healing networks so it can actually take care of the problems as it finds it, which ultimately gets to a much more, at the end user experience, your experience will be a much more consistent, it'll start to feel like your wired network. It'll feel like your fiber at home experience.
Yeah, it's gonna correct itself. So I wanted to move in to a little bit of the data. So why is real-time user data? Why is that important?
Well, I mean, location is probably a good example. If you think about trying to bring a great user experience, wayfinding experience to someone who's walking through a airport or a mall, you're walking through a mall, you're moving at a meter per second, right? So every second, all the data I had about you from a second ago is no longer relevant, right? So every second I basically have to be gathering a bunch of information and trying to make an estimate of where you are in space. So that's an example where, you really need real-time architectures that can basically ingest a lot of data at scale, and basically process a lot of data real time.
Yeah, I may even elaborate on a little bit in that. There's a fine line between personalized location-based services being productive and annoying. And if you're getting a direction when you've already passed the door or a hallway, or you're getting a notification when you're a block away from the store, then that's annoying. That's actually a hindrance. So the real-time data processing and submission is key, right? And so that kind of elaborates a little bit on what Bob was mentioning.
I mean, I think the other example is the hotel, right? You want the front desk to know about if the customer actually has a problem. You want the front desk to know about that problem before the customer calls. And so, when someone walks into their room, when you go to your hotel room, what's the first thing you try to do? Besides turn the light on.
Yeah.
You turn the light on. The next thing you do is
Wi-Fi.
Can I get to the internet?
Remove the comforter.
Right. And so getting your Wi-Fi,
I think Wi-Fi is more important than the lights, by the way.
Yeah, fair enough.
And so, to be honest, a lot of people, the first thing they do is to make sure they can get their internet working, and then they worry about everything else.
Well, and then the irony is when the Wi-Fi doesn't work, they blame the Wi-Fi, and it could be 1,000 other things that aren't even wireless related, but that's a different story.
And that's the kind of real time. By the time that happens, you want the guy at the front desk to know, hey, guy in room 101 has a problem, and he's about to call you up.
But how accurate is the data? I mean, like sometimes I can tell the lag because like I'll text someone and and they're next to me, right? And you can see that they haven't received the message. Like, how accurate is that? What is the lag time like?
I mean, for us, the lag time is, for us, we're getting our data, and this is why we built our own access points, right? Because that is the source of truth, is the data we get from, where you're connected to the network. And we have two sources of data. We get what we call synchronous data every 10 seconds from the AP that gives us, 2 to 10 seconds, that gives us a status of its health. But the other key thing that we get, that we used to never get, is basically asynchronous user state data, right? And we get that every time something happens to you, right? Every time the user changes your state, whether it be authentication or coverage or connectivity, those events get sent to us immediately.
Yeah, and you have to create different classifiers to your question of how do you get that level of accuracy. There's different classifiers that help you drill down. So, for example, there's one classifier that's showing how long it's taking a user to connect, from start to finish, how long is it taking to connect. There's one classifier that's saying how long is it taking users to roam. When you move from one access point to another, what's that connection? There's another classifier that's throughput. How much bandwidth are you passing? So there's all these different classifiers that all add up and account for what the user experience is. And so those are that's part of the AI, is you got to collect that and classify it and then make heads or tails out of that and then figure out how to optimize that.
I think that's a great transition to user experience. So just moving into user experience, I think we spoke a lot about that today. What is your ideal user experience like?
So from an IT standpoint, I mean, for us users is interesting, right? So technically our user is an IT person that's actually deploying wireless, and then they're giving wireless to their users who's the end user, right?
Mm-hmm.
And so there's kind of two levels of user experience. To the IT guy, I always joke, when was the last time someone complimented you on your Wi-Fi? So for us, the ideal user experience is, they get compliments on their Wi-Fi instead of people saying it sucks, and they know exactly what's going on, they're ahead of the game. To the actual person, with the phone or the laptop, the ideal experience is the Wi-Fi is reliable,
Mm-hmm.
it's fast, they don't complain about it, and they get all the location experiences they want, built into the system, and it's just, it's just a better end user experience. So I think there's two ways to kind of look at that question.
Awesome. And I just wanted to give you an opportunity to brag. Have you received any positive feedback from your customers, or your customers and users?
No, they all hate us.
I mean, I think,
That's what I thought.
I think I think for us, right, I mean, what I can tell you is that, we are, in our first year, we more than doubled our original plan, which kind of speaks back to customer feedback and basically acceptance of what we're doing. I think the other thing we've seen here that was, we've actually taken, we have some very big name logo customers,
Mm-hmm.
Which I think really represents what they see disrupted. These are very big customers who are betting on a small startup.
Yeah, I'll maybe even couch that a little bit differently. So we've been shipping for about a year and a half, and we have about 300 customers right now, and about 25 are in the Fortune 500. And so to Bob's point, when you got big retail chains like PetSmart, or the top e-tailer company out there, or Facebook using us on their shuttle buses, or Disney Resorts, Swan and Dolphin using us, those are their businesses rely on the Wi-Fi and the customer experience. And so the fact that they have kind of bet their wireless and their businesses on Mist is a huge testimony of what we're doing. And so we're just extremely excited and extremely proud and extremely grateful that we've had a really good first year and a half, and we're really excited about what 2018 means.
Yeah, that's awesome. I just really can't wait because, I think it's annoying when I want to, do a snap or post a video on social media. It just doesn't work. And when we're creating content, I think Wi-Fi is very, very important. What is one wisdom or story about Wi-Fi that you wanted to share with the community?
A war story, is that what you asked?
Yeah, I think in the context of AI, I can give you a couple of examples where this, AI is starting to make a difference. And probably people in the wireless world especially, would appreciate this. We had one wireless customer who had our system, and he basically tried to turn off the lower data rates to make things better. It turned out that really caused a big time to connect problem. And basically had all the students, he had a college thing going, and basically had all the students complaining about time to connect and how hard it was to connect. It turned out that, and this I'm saying, when you look at these wireless problems, it's usually a combination of things. It's like an airplane crash, right? It's not one thing. It's a combination of unrelated things that cause a problem. In this case, it was really turning off those lower data rates, really hit the DHCP server that was misprogrammed and wasn't doing broadcast. It was doing broadcast instead of unicast, which really created a broadcast storm, was kind of what pushed the whole broadcast storm. So that's an example of where you have a wireless network, you do something, you don't think it should have any impact on your DHCP server, but it does. And where this AI stuff comes in very quickly it identifies an anomaly, something happened that should not have happened, and then quickly does a correlation against, what caused that anomaly. So basically, instead of taking hours to figure it out, they were able to sort it out in a matter of minutes and basically figure out, yes, that configuration change is what caused that problem. Another interesting kind of AI story was really around, one of our big retail customers. This is a class he's had problems for 6 months or so. He hasn't been able to figure it out. This is really around data mining. right? Being able to go through and find which device is actually causing the problem. You know, this is like a barcode reader that has the wrong OS on it. And you basically have to track down that, hey, there's a particular device out there that has a bad thing, a bad OS on it, and you want to identify that device. You know, with this data mining AI stuff, you quickly can go through the data and basically figure out, of all these devices, this one here is basically the problem is associated with this device and this OS type. So those are kind of Wi-Fi stories where AI is starting to make a difference. You know, it's starting to help IT guys get to the root cause quicker and faster than they have in the past.
We are speaking with Bob Friday and Jeff Aaron, CTO and VP of Marketing from Mist Systems. So Bob and Jeff, how do we find you guys? Do you have a website?
Yeah, we do. It's www.mist.com. And I'm not going to tell what Bob and Sujay, our co-founder, went to get a 4-letter domain name, but they did, and we're real pleased with it. And we encourage everyone to go check it out. There's lots of good resources on there.
Yes.
Yeah, we convinced someone who.
So the website is mist.com, and
that's correct. Yeah.
I just wanted to thank you and Bob for talking to us today. Thank you for your time.
Awesome. Thanks for having us, Michelle.
Yeah. See you soon. Bye-bye.
Take care.